Great, and welcome everybody to the River Herring Forum, first meeting of 2026. We'll circle back to this again at the end, but we meet twice annually, virtually, obviously. And James and I were just talking before this meeting. I think we are going to change the date of the fall meeting. What did we say, James? October 26th is the date we're looking at. So we will obviously send folks an update once we finalize that date, but the calendar for ASMOC kind of threw us for a little bit of a loop for their annual meeting, so we had to bump the date there. The other update relative to the administration of the River Herring Forum is that we're now using a Google form to change your participation in the listserv. So if you want to be added to the list, the email distribution, or you want to be removed, we'll do that. We'll track that all through the form, so you don't have to send James and I an email. We can keep track of it through that. So from now on, we'll intend to include a link to that Google form at the end of the of every email that we send out, just so folks can manage their participation in that email list as they see fit. So otherwise, yeah, thanks to everyone for joining today, and thanks especially to our presenters. We got a few technical presentations on the agenda today, so thanks to all those folks who stepped up to share their work. As always, we're looking for your suggestions, either for work that you want to present, or maybe an interesting presentation that you've recently seen that's related to river herring. Please keep feeding that the suggestions to James and myself, so that we can continue to bring the most interesting presentations to this forum to be of greatest use to all the practitioners who've joined us today. So with that, I'll pass it over to James, and he can kick us off with any other River Herring Forum related updates, and then obviously Atlantic States Marine Fisheries Commission updates. So go ahead, James.
Hey, Jonathan. Yeah, really quick from the commission side, things have been pretty quiet for shad and river herring. For anybody, if anybody's new, I'm the F&P coordinator for shad and river herring at the Atlantic States Marine Fisheries Commission. From our management board perspective, things have been pretty quiet, although we are monitoring the action of the New England Council that I'll defer to Jamie to present an update on. That is, we have a complementary plan with Atlantic herring from the commission to the federal plan. So depending on what happens with that action, action may come through the Atlantic herring side of our management board on our side, as opposed to the shad and river herring board. So we're kind of, from my perspective as a shad and river herring F&P coordinator, we're kind of monitoring that, and we'll, as options get developed, we'll consider bringing in the shad and river herring AP perhaps as appropriate. So any meetings that are set on the schedule for our AP or TC or whatever that's relevant to that will be posted on our website at the time. With that, I think that's all I have, and then happy to pass it over to Jason.
Thank you. This is Jason Didden. I'm the plan coordinator for the mackerel squid butterfish FMP at the Mid-Atlantic Fishery Management Council. And is it possible for me to share my screen or not? Okay, cool. So yeah, likewise at the council, not a lot of direct river herring and shad stuff going on in 2026. I'll just flag the easiest way for folks to check things to the council is if you go to the About and then Strategic Plan and then 2026 Implementation Plan. It's just a good resource for, you can kind of go through pretty much every action and deliverable that the Mid-Atlantic Council is going to do in a given year, goes into this document. And the main thing for river herring and shad is we have an Inflation Reduction Act funding project that we funded, an extension of some previous work to try to use environmental data to predict river herring and shad abundance. Or not abundance, river herring and shad occurrence, and Atlantic herring and Atlantic mackerel occurrences. And if you're on the council's website and it's under under the climate tab, and then IRA funding for climate ready fisheries, this was kind of the funding. There's a number of all the councils were given some money for climate type projects. So one of the ones that we spun up relatively early was this bycatch reduction project. And so there's a little brief there. If you click on the project brief, you'll get some more information. We have a link to the actual website that gets updated every Monday. And essentially, we've got a product of maps for Atlantic herring and river herring, and then a product of maps for Atlantic mackerel and river herring. And so it's kind of in like an initial trial run this year. The model seems to do a half decent job of predicting based on past data where things would have occurred with environmental data, and the contractors, researchers at University of North Carolina are kind of putting it out there to fishermen, getting some feedback on it. Some of the feedback we've gotten so far is it's just kind of too broad scale for them to really use it, but it's intended as one potential tool in the toolbox. If it doesn't prove to be useful, the idea is we're going to run it for 26, modify it, try to improve it for 27, and then if it's not useful to the fleet, then it's not necessarily we'll continue it, but it's idea is it's a tool in their toolbox as they're evaluating where to fish for herring and mackerel, and based on predicted environmental conditions and past occurrences of herring and mackerel and river herring, and the kind of environmental conditions they occurred in, can we try to predict some areas where you're more likely to hit the target species and less likely to hit river herring. So that project will be running for 26 and 27. I guess the other thing I'll flag is, so the council did update, adopt new Atlantic mackerel specifications for 26 and 27, with some substantially increased quotas for Atlantic mackerel based on that assessment. But because regulatory changes are moving really slowly, even though NIMS increased the quota for mackerel, the trip limits couldn't be changed. The trip limits are still very low, really only allowing incidental fishing. Those might get changed May, June, given the assessment was delayed, so council action occurred late in the year. So those trip limit changes that are what the more directed fishing occurs under are at this point most likely, I think, kind of in a May, June timeframe, so not really available for that typical early calendar year directed fishing. So that is my summary of things for the Mid-Atlantic Council. Thanks.
Thanks, Jason. Yeah, interesting project, and maybe it might be interesting to have like a little run through of the tool and the prediction river herring incidence prediction tool at some point. I can't remember, maybe you did that at the fall meeting.
Yeah, and the researchers did a presentation for the council, so I can send a link to that if folks want to kind of can get an overview via that at a later time if they want. You can put that in the notes or something.
Okay, yeah. Maybe I did. Maybe that's what I was thinking. I had seen that presentation because I found it on your website. But I'll go ahead and send that link out again. So thanks for the reminder. We'll be interested to see how that's received by the the fishing industry. I think it looks like Jamie's ready to present on behalf of the New England Council. So Jamie, please take it away.
Everyone, good afternoon. Jamie Cornan from the New England Fishery Management Council. Just want to provide you with a brief update on what the council will be working on this year with respect to Atlantic herring and focusing in on river herring and shad. Our council sets priorities for the next year and its December meeting. So in December 2025, the council set its work priorities for this year. And at that meeting, they discussed Amendment 10, and you may recall that Amendment 10 had river herring and shad management measures included. They decided to move that section to an action we're working on now for specifications for sea herring for the next 5 years and other management measures for sea herring. So this action that's in the top line of the quarterly outlook would include 5-year specifications for herring, river herring, and shad measures and other management measures in this annual action. And so what we're working on now is the plan development team is working on tasking related to river herring and shad. We had a meeting, excuse me, about a week or so ago where we talked about one of those tasks, and we'll be continuing to work on those as the first 2 quarters of the year, and then developing some measures for the council to consider and also impacts analysis. The opportunities that folks will have to participate in the process include listening to our plan development team meetings. Often I'll ask the public if they have any questions, if they like to ask any, if we have time, but also at our advisory panel meetings and our herring committee meetings, and of course our council meetings. And so these purple boxes show when the council plans to discuss this action. So the next 3 meetings, April in Portland, Maine, and that will be an update on the action. June in Mystic, Connecticut, and this will be an update on the action. And depending on whether this action is an amendment or a framework, the council may, if it's a framework, need to initiate the action. It's a process point. We're anticipating final action in September. I believe that's in Plymouth, Massachusetts. And then the council staff will work with the plan development team to prepare the action for submission. And then it will undergo a review by NOAA Fisheries with the idea that it be implemented by January 1st. There's a couple other items on here. This year, there's a stock assessment for Atlantic herring. That peer review will take place in June in Woods Hole at the Northeast Fisheries Science Center. And also in July, we would, August, our scientific and statistical committee will meet to work, prepare recommendations on the overfishing limit and the ABC, the annual biological catch for, the allowable biological catch for herring, sea herring, at that meeting as well. Just as I mentioned at the beginning, our council sets its priorities 1 year out. Later this year, the council will talk about priorities for next year, and we will work with our various groups to develop a preliminary list of what the council's work priorities might be. That last meeting is in Rhode Island and rounds out the council meetings for the year. I'm happy to take any questions if there are any on where we are in the process and how things are working. And thank you for the time today. I appreciate it.
Thanks, Jamie. Are those meetings, the April, June, and September, are they scheduled? And I guess if so, I'll make sure to share them out with the forum so folks are aware, how they might attend.
Yeah, we schedule our council meetings actually multiple years in advance, but if you go to our webpage, there's a tab called Council, and all the meetings are there, and you can now see the April agenda is posted for our upcoming meeting.
Okay, great. I will I'll make sure we send that out with our post-meeting recap. So thanks as always to both you and Jason for coming to give us our council updates. We have a minute here for any questions for either Jamie or Jason. So feel free to raise your hand and we will patch you in. While we may wait, yeah, Jamie, so with the, and forgive me, I feel like understanding the council processes is a learning expedition for me, and as I imagine it is for others, but my understanding is, protective measures for shad and river herring, things like time area closures, could be considered as part of the action or framework this year, and it's still being evaluated at this stage. And at some point, I don't know, you want to speak a little bit more to how the process there, how it would be evaluated, and at what point the council would have to make a decision or would have to decide, what, if any, measures might be the best path forward?
Sure. So just I pulled up the council agenda just so folks have it. So April 15th is when the herring committee report, that's what you'll need to look out for our agenda. The Atlantic Herring Committee report will be 3:15 in the afternoon on Wednesday, the 15th, April 15th, and we will, at this meeting, we will talk about the timeline, the scope, and a draft outline of the alternatives that we expect will be included. So our process is to start from analysis and develop some analytical work to support the development of alternatives. So that's where the plan development team really comes in, with some input from the advisory panel. And this is where we'll look at things like different ways to calculate a river herring and shad catch cap, or develop a species distribution model that could support siting of time area closures. So that's the analysis part that happens. We present that work and then iterate through with the committee to develop alternatives based on that work. And we look to do a range of alternatives that covers the goals and objectives that the committee and the council are trying to achieve. So that means sometime in June, we expect to kind of know pretty well what is going to be included in the action, although some of it may need some refinement all the way through to the final decision meeting, which is scheduled for September. When we have that range of alternatives developed, we analyze them, we do an impacts analysis, and that includes looking at the various valued ecosystem components. That's the impacts analysis will include things like biology, ecology, habitat, social and economic impacts. And that's presented to our council at its September meeting to help for decision making. Then after that, we prepare a final submission document, which has to comply with all appropriate regulations and laws. And so there's some additional policy work that happens after the meeting before submission takes place.
Okay, so just broadly, in April, there will be, sort of the concepts of different alternative, management measures will be considered. In June, they'll be a little more firmed up, it sounds like, and maybe some refinement there. But and then in September is kind of when the council will vote on, whatever management measures are developed.
And September is the current timeline to stay on track with implementation as soon as possible for January 1 of next year. We have had actions take a little bit longer if there's more analysis needed, or we need to refine the range of alternatives with the council. So right now we're working under September. I guess it's possible that could get pushed out, but the current timeline we have, every council meeting is an opportunity to check in on how things are going too.
Right. Okay. No, that's super helpful. Thank you so much for helping us understand the process and where and how folks might be engaged and make comment if they so desire. Anything else, Jamie, before we switch gears here?
Feel free, anyone, to reach out to me if you ever have any questions on our process. You can call my extension or email. I'm happy to answer your questions and help you figure out maybe what's the best meeting to attend or how to comment, any of those things. I'm more than happy to help you and help you, the larger you, in our process. Thank you.
Great.
Same
Thanks.
for Jason here at the mid. If folks are contacting, all staff contact information's on our website. So if I can be of assistance, don't you or anyone hesitate to reach out. Thanks.
That's great. Thank you both. I don't know, James, you want to pull up the agenda real quick, or do you want to? We can just roll right into our first technical presentation here. We have Robert Vincent, Rob from MIT Sea Grant. He's going to give a presentation on a recent publication that they completed entitled "Nutrient Transfer Dynamics of Anadromous Alewife in Freshwater Spawning and Nursery Habitat." So with that, I think, Robert, hopefully, looks like you have been granted access to share your screen.
All right, I'm Rob Vincent. I'm with MIT Sea Grant, and I'm going to talk to some recent work we did on nutrient transfer dynamics of anadromous alewives in freshwater spawning and nursery habitats. I'd like to recognize the collaborators and co-authors, John Logan and John Shepard at Mass Division of Marine Fisheries, Michael Power, University of Waterloo, Steve Hurley, formerly of Mass Wildlife, and Kevin Bennett, MIT Sea Grant. And John Logan did a lot of the work with the analysis of stable isotopes as well as the mixing models. And John Logan, John Shepard, Steve Hurley helped quite a bit with all of the sampling and field work on this. And okay. All right, sorry about that. Okay, so the objective of this study was to evaluate effects of fish passage, improvements on river herring food webs, and habitat connectivity. We had 3 working hypotheses for alewife foraging, marine and freshwater contributions to juvenile and adult river alewives, for energy transfer, ecosystem connectivity, and food webs, marine and freshwater contributions to freshwater fish predators, juvenile alewife contribution to freshwater fish predators, and then also mucus as a non-lethal stable isotope sampling method. We had 3 study sites. Our 2 control sites were Great Pond and Herring Pond in Eastham, Massachusetts on Cape Cod, and our restoration site was on Fresh Pond in Plymouth, Massachusetts. We did some habitat mapping and characterization using an over-the-counter fish finder sonar unit. This was done to ensure compatibility among the 3 different types. We collected fish and plankton samples and some vegetation samples as well for the isotope analysis. With adults and juvenile river herring, we used dip nets at fish ladders. For freshwater predators, fish predators, we used electrofishing and gill nets. For freshwater forage fish, we use dip nets, and for freshwater and marine plankton, we collected using 5-gallon jugs from those water sources. Stellwagen Bank is where we got the marine plankton. Stable isotope analysis, we looked at carbon, nitrogen, sulfur isotopes. Samples were prepared at the MIT Sea Grant Biolab and processed at the stable isotope labs at UNH, University of Waterloo State, and UC Davis. And the mixing model we used to assess contributions of marine and freshwater derived nutrients to juvenile and adult alewives, and we use the mixing model and R package for that. So our results, we showed stable isotope values of out-migrating adult alewives from Great Pond differed from in-migrating in greater differences for mucus and liver compared to dorsal muscle. For all 3 tissues, Out-migrating alewives had lower carbon and sulfur, but higher nitrogen values. Medium freshwater food web contributions to adult alewives were approximately 90% for liver, 83% for mucus, and 19% for dorsal muscle. And in addition to prior marine foraging, several of in-migrating adult alewives had estuarine prey, grass shrimp, P. in their stomach contents. And then for juveniles, medium freshwater contributions were 95% for all three sites. Great pond for both liver and muscle, and for herring pond for muscle. And you can kind of see these relationships in the figure on the right. The triangles are the mucus, the circles are liver, muscle is the squares, and then the dark ones are out migrating, and the clear ones are in migrating. Adult alewives CN values were lower for out migrating than in migrating individuals in Great Pond for both liver and dorsal muscle, while mucus did not change. The majority of out-migrating alewives were female, so the condition shifts are demonstrated by CNN ratios are largely reflective of energetics for female alewives. All fish predators in fresh pond had low liver and muscle sulfur values, similar to freshwater particulate organic matter. And distinct from alewives derived marine sulfur. Estimated freshwater contributions were greater than 98% for both tissues for all freshwater predators. Again, that's muscle and liver. And a few species did not reflect higher levels of marine, or did reflect higher levels of marine derived contributions, and those were in juvenile eels, white perch, and yellow perch. And juvenile alewives were observed in the stomach contents of largemouth and smallmouth bass. And you can see some of these relationships on the right relative to the plankton. So the pink dots are the adult river herring, and the blue ones are the juveniles. And then FW freshwater and MARs marine plankton. And then mucus in migration, adult river herring sulfur and nitrogen values were similar to liver and muscle, and out migrating adult river herring mucus sulfur and nitrogen values were similar to liver. And all sampled biota from herring pond had elevated sulfur values reflective of marine sulfur, and we concluded that was representing marine water intrusion during high spring tides. And you can see that photo right there shows the marine water just rushing into this pond. So our conclusions, the observed shifts in adult alewife stable isotopes toward freshwater sources between in and out migrations demonstrated active feeding during pond residency. These results are counter to earlier paradigms characterizing freshwater ecosystems as only spawning habitat for adult alewives, with fasting previously assumed during this life history phase. And our results comparing freshwater particulate organic matter and marine plankton as diet sources provide additional support for active feeding in freshwater environment by adult alewives, and demonstrated the transfer of freshwater nutrients back to the marine environment in out-migrating adults and juveniles. And stable isotope shifts were most pronounced in liver and mucus tissues, which are known to undergo rapid turnover in fish relative to dorsal muscle. And despite active feeding, out-migrating adult alewives had lower liver and muscle lipid stores than in-migrating conspecifics, as demonstrated by the CN ratios. And this indicates that the energetic cost of spawning exceeds freshwater energy inputs acquired while feeding in these pond systems prior to emigration. The freshwater fish predators had tissue stable isotope values mainly reflective of freshwater energy sources, suggesting pulse of marine-derived nutrients provided by in-migrating alewives do not provide an energy source over sufficient timescales, weeks or months, to be reflected in the predatory fish tissue isotope values for these pond ecosystems. This could be, well, it may be different for much larger systems. It could be more pronounced. That is something that needs to be done, this type of work on larger systems. Anadromous origin juveniles undergoing rapid growth may reflect the isotopic composition of freshwater feeding environments within a few days or weeks. And juvenile river herring no longer carried the marine isotope signal and were more difficult to distinguish from resident freshwater prey, yet were documented as prey in stomachs of freshwater predators in our study. So in other words, there may be higher consumption of juveniles, but since they now carry the freshwater signal, you're not seeing that in the marine feed. Our results highlight the importance of establishing site-specific stable isotope baselines when using stable isotope analysis to trace marine and freshwater source contributions. The elevated sulfur in Herring Pond is likely due to occasional intrusions during the spring high tides, and such events were documented during the study. Likewise, elevated nitrogen in Herring Pond is likely due to anthropogenic sources in this impaired pond. And mucus stable isotope shifts for in and out migrating adult alewives were similar to liver, representing a non-lethal sampling method, especially important for species of concern. And the results of this study demonstrate the net benefits to restoration, including fish passage improvements, and more specifically, the ecosystem benefits of introducing alewives into freshwater spawning habitats in terms of energy transport and trophic relay for freshwater recreational fisheries. In our study, we were able to detect marine contributions in river herring with as low as 490 alewives per river kilometer. Our study demonstrated sustained adult alewife freshwater foraging based on tissue stable isotope values, as well as the utility of mucus as a non-lethal tissue for use in future SIA studies in river herring. And partial and complete reflection of freshwater derived nutrients in tissue stable isotope values reveals the export of nutrients to the marine environment, and the lack of detectable marine derived nutrients in most sample freshwater fish predators suggests limited nutrient subsidies in freshwater systems. However, larger runs may provide more insight into this. And the work provides insight for fisheries and resource management planning, conservation and management of alewife populations and habitats and resources that they depend on, and demonstrates ecosystem and economic cultural benefits, habitat restoration, maintaining ecosystem connectivity through fish passage improvements. And that's what I have. So if there's any questions, you have to answer.
Thanks, Robert. It looks like we did have one in the chat here from Alan Weaver. Alan, do you want me to read it, or you're welcome to unmute and ask your question?
Yeah, I can. Yeah, if I'm unmuted, I can answer. I can ask the question. Yeah, I was just thinking about, like, the further south you go, those fish tend to only spawn once, whereas up in the north, have you looked at any other literature to see if studies like this have been done further south, and would you expect to see less freshwater feeding further south, because the fish up north, they basically have to preserve themselves to make sure that they can make it back again to spawn.
Yep, we did look at the literature, and the references we found were mostly, as you noted, up in the north. So this would be good work to do down there. You know. So at this point, I don't have any insight into that.
Right. The thought that comes to my mind is, in those places where you have maybe iterative parity is like, waning. Could you look at, would you think that, greater food availability or greater syncing between, good high quality forage and, could lead to, greater post-spawn survival or something like that? It'd be a tough study to conceptualize given how fragile those post-spawn fish probably are, but it's very interesting to have those data, and it'd be interesting to see if, to repeat the study further south to see, where you have maybe some heteroparity happening. Do you see that that same foraging activity?
I think repeating it in other regions would be very interesting, as well as different size runs as well.
Right. I have a question. So you didn't pick up the marine signature in any of the predators in the pond, but you're talking, smallmouth, largemouth bass are probably the larger predators that you'd see. It's just thinking there's probably gape limitations on whether or not you could eat an adult alewife in some of those systems. And curious if you thought about, do you anticipate maybe looking at different types of predatory fish? You might come up with a different answer, or for larger predators.
Yep, we did look at a suite of predators. We looked at the large smallmouth bass, the white and yellow perch, chain pickerel, and we looked at larger sunfish. And the ones that were showing the signal were the two perch, some juvenile eels, but we did find the river herring in the stomachs of the two bass species. So it may just be they weren't feeding long enough on them, or they're not widely feeding on them. It's
right.
Uncertain right now.
Gotcha.
And also, if they're feeding on the juveniles, with their rapid change over the freshwater diet and the freshwater isotope signatures, then you won't be seeing that marine derived.
Exactly. Right. You wouldn't pick up the marine signature from the juveniles.
Yeah.
Yeah. Very interesting. And I think, given certainly in the Chesapeake Bay, concerns around nutrient, eutrophication and, nutrient reduction strategies have always felt like, migratory fish might be a bit of an unsung hero if their numbers were great enough to actually help with the, movement of nutrients out of the estuary where we're, concerned about eutrophication. So it's great to see more work, reinforcing that ecosystem service, and appreciate you coming today to share your recent paper with us.
Okay, thanks for having me.
Okay, so this is some work that I conducted as part of my dissertation at Clemson before joining the Nature Conservancy. But I'm still involved currently with this work while we navigate through this kind of new climate that we're dealing with. So this is about a kind of an environmental flow prescribed such that migratory fish can move over top of these dams. I'll give you some background and some information about why we chose to do this. It seems pretty obvious that it would work, but there's a lot of factors that have to go into play to make this happen. This is novel in that it hasn't been done to this scale purposefully, at least in this size river for low-head locking dams. There may be folks that this kind of regularly happens in your area for smaller systems. It does naturally submerge in this area, which is good. But I'll really I'll show you why this is so important. So I'd like to introduce my co-authors, Troy Farmer, Kyle Rachels, Ashley Hatchell, Jeremy McCargo, Fred Scharf, and Julie DeMeester. A lot of the funding came from the Nature Conservancy and the U.S. Army Corps of Engineers. Clemson Wildlife Commission and UNCW were intimately part of this. Okay, so I'm going to skip through this. We all know how fragmented our rivers are. So, I mean, we're looking at over 90,000 in the Southeast alone, and 90% of our CMS listed species have been in decline according to the Conservation of Migratory Species. So, you know, and I use these old photos. These are the primary fish that assemblage, anadromous assemblage that utilize the Cape Fear River, which is our study river. There used to be, I mean, just, you know, loads and loads of river herring, particularly blueback herring. A hickory shad was also in the mix. Now we don't see those two species nearly as often, but we do have a decent population of American shad. Striped bass are dwindling. Atlantic sturgeon are endangered in the Carolina segment, but they are. We're seeing a population in the Cape Fear, and the Cape Fear, you know, past these, there's 3 lock and dam structures, which I'll show you here in a minute. This was from back in 1916 when these things were starting to be built, and the last one was built in 1935. Well, this was to carry goods from Wilmington Harbor up to Fayetteville, and then shortly thereafter, like within a couple of decades, trains and transit over land dominated shipping goods. And so they didn't really have a purpose after that. But now these lock and dam structures provide a pool for municipal intakes, which is important in the region. And so we're talking about southeastern North Carolina, the largest watershed within the bounds of North Carolina. Roanoke's a little bit bigger, but that goes up into Virginia. And you can see based on these stars where we're at. We're kind of in that lower half or lower third of the river. Okay, we have 3 different locks and dams. So going from the furthest upstream, Lock and Dam 3, on down to Lock and Dam 1. Lock and Dam 3 is a 6 to 8 foot drop. That's your standard, you know, lock and dam with those plunging flows that you see. Lock and Dam 2, there's been some boulders added to stabilize that low head dam. So at elevated water, you know, the fish may be able to move up through those rocks. It's not quite the plunging that happens at LD3. And then Lock and Dam 1, there's a Nature Lake Fishway that has been constructed. One of the biggest ones, if not the biggest on the Atlantic coast, at least one that was created back in like 2012, 2013. It's since been modified in 2021 for 3 distinct pathways with resting pools and a little bit better slope, but we're still seeing issues with that. But Cape Fear River fish passage efforts in general have been going on for a very long time. Early in the 60s, there was an idea of why don't we use conservation lockage to allow fish to pass through these lock chambers the same way a boat did. There's also some derelict fish ladders that were based on salmon fisheries, so those generally don't work for the fish that we have unless you're at a very high water level. And in 2013 through 2021, there was the fishway built, and then there was lockage occurring at LD2 and LD3, those upper 2, and then that stopped because of mechanical failure. These chambers don't function anymore. They're not, the gates simply don't function. And so that's why I said, like, we had to find something else to be able to move fish above these locks and dams. And that's where e-flows came into play. So we've got the fishway at 1, you know, for some species that works fine, but for others, not as much. Shad tend to be able to pass the fishway okay, but sturgeon and striped bass are having major issues. But we wanted to specifically look at e-flows and how we can accomplish this. And what TNC and the Army Corps of Engineers did, they initiated a workshop, I think it's back in 2018 or 2019, with a number of experts. And one of the ideas was to have anadromous fish spawning cues and also some pulses to submerge the locks and dams in order for these fish to pass over top. So that's what we're talking about now. But this was a full like prescription design for different objectives within the basin. And today I'm only talking about a part of that. So here's our study system. Again, southeastern North Carolina. One of the main areas of focus is Jordan Lake, which is right here, and it's on the Haw River arm, and then there's the Deep River arm. So combined, these two areas create the main stem of the Cape Fear River. The Deep River is unregulated, Haw River is regulated, okay? So in order to accomplish an E-flow, we have to have adequate water coming from the Deep River and then adequate water within Lake Jordan to ultimately allow fish to pass over such that fish can get to this nice little green X, which is the putative spawning grounds for shad and other anadromous fishes. And then there's a buckhorn dam, which is a complete passage impediment. The fish won't be getting up over that. So that's as far as they can go, but that's still, you get them up to Buckhorn Dam, and that's still like another half of the river available for them. And what you have to do to get to this point, there's all these constraints and enabling conditions, especially for a river this big, where you have to have adequate flows in the reservoir. There are limited operations that the gates can allow as far as maximum release, which is that 340 meters per second, or cubic meters per second. And then you have to be within authorizations because you don't want to flood communities downstream. They have to have time to prep the facilities. So those are the constraints. Enabling conditions, you have to have enough upper watershed rainfall. The deep river arm, which comes in right here, has to be flowing naturally enough. I think it's above like 7,000 CFS, which, right, 142 cubic meters per second, to be able to initiate to get the submergence flows to occur. And the reservoir elevation level has to be within the sky curve, and there has to be flows above target for the river forecasts. So for this, 7 days out, we're monitoring weather. We're trying to figure out, are there any potential precipitation events, big things happening across the country. 3 days, we're analyzing river flow conditions and running predictive models, communicating with folks. 1 day prior, we prepare operational gate instructions directly with the Army Corps of Engineers. So the Jordan Dam is an Army Corps dam. Jordan Lake is an Army Corps lake. So this is how we're able to accomplish this. And a lot of communication has to happen with basin stakeholders. And then during, we want to, observe whether this is occurring or not. We want to communicate with researchers and the lock masters that are down there on the water. And then we also have real-time time-lapse cameras that we can just, that are enabled, cell-enabled cameras. We can just press a button and have that available to us within a few minutes. Okay, so here are two different types of E-flows that we're talking about. So on the schematic, you have time on the X flow on the Y. On the upper two panels, we're talking about an extension of the natural pulse duration. So this is during what conditions? You have this nice pulse coming in from the Deep River. You have dam releases above, like at the perfect threshold to make sure that it's over that dam submergence flow at Lockheed Dam 3. And then in this orange, you have this perfect scenario where you have the peak and then you just have that flow sustained for as long as possible above the dam, right? So a second scenario is where we enhance the natural pulse magnitude during dry conditions. So like if we see a pulse within the Deep River and we have enough storage capacity in Jordan Lake, can we create a pulse that's big enough to at least overtop the dam for a little bit? This actually is important because a lot of times there's fish just waiting below the concrete walls to pass. So any little, any little pulse that we can submerge the dams, we can get fish over top is a good thing. All right, and so we're documenting this with the cellular cameras. We have field observations, and we also have the photos relative to the USGS hydrograph. Results, moving into some of the results, low flow conditions look like this. This is Lockton Dam 3. There's only 57 cubic meters per second. So you're seeing those plunging flows, the hydraulic jumps, the churning below that, a boat can get swept in, and that's where you have really bad dam safety issues associated with those churning flows. Well, that's not good for fish either at all, really. And so there's this high drop. Well, under a dam submergence condition, in this case, this was about 535. We tend to get a full inundation around 496. And that what we're considering as dam submergers fully inundated, you're seeing that laminar flow over the sill crest. There's negligible drop. You might see some waves here and there, but fish are able to pass over, okay? And that's ideal conditions. So there may be other a little bit lower conditions, or on this back end over here, on that far side of the river where you see those trees and you see a little bit of whitewater occurring, that's that old remnant salmon ladder that at high flows, but maybe not high enough flows to fully inundate, fish may be able to use that and maybe get over that one or two last steps before passing over. Okay, in each of from 2020 to 2023, even into 2024, we've had between 1 to 3 events that were high enough magnitude. There were 5 occasions where they were extension of the natural pulse duration, and 5 occasions where we tried to get that enhanced the natural pulse magnitude. So you can kind of see the difference between, say, like right here in 2020, you see this spike in the Deep River, which is in blue. Spike in the Deep River, which is in blue, and then you see the extended green line. This is where extending that duration. If you move over to panel B, you can see that occurring in 2020 versus, like, say, 2023. We approached dam submergence on a couple of occasions, but we didn't get it there the way we wanted to, except for maybe in mid-April. So that's what we're looking at for the past, from 2020 to 2023. And this is just a series of photos that kind of show this particular event in 2022, where you start real low and then you build up. And at 453, there's kind of that wave that's still there. Panel C, I mean, we're talking about significant flooding and then big flood, in this mid-March. And really what happened here is this initial pulse and the submergence was our E-flow, and then a big natural submergence event came in after that. So, so we had 2 really good back-to-back events for submergence in that time frame. Okay. So E-flow is critical. The timing of this is critical. Fish need to be present to pass. That's a no-brainer. There's species-specific migration timing. Blueback and alewife, depending on where they are, especially up north, likely sooner. I'm not sure, but that's something to consider, is the timing associated with these flows. Ideally, you get submergence flows at kind of that upper end peak migration to get the most bang for your buck. And then you have the issue with mid to late season fish stacking behind the dams, which can cause substantial migration delay and issues with energetics and the whole deal. So that can cause issues. So fish were provided intermittent passage to upstream habitats. We know that. The predictability of future dam submergence flows remains uncertain due to potential climate-induced variations in precipitation patterns. And this is looking back at the proportion of spring days that are greater than that dam submergence at 496 And you can see there's only about on average, there's only about 7% of the days in a spring that are of high enough to submerge these dams. And what you can also see is it could be dam operations, it could be the climate signals or whatever, but we're seeing, you know, below average dam submergence occurring. We're also learning stuff along the way. So like we're using adaptive management and learning additional flow targets. So downstream above the Nature Lake Fishway, which is right down here in the bottom right corner, there's actually a side channel that is just north of that area within this floodplain. And there's multiple connections within that. Well, there's two openings at site 1 and site 2 right here, which corresponds to these photos. And if you see the top, you know, these are timber dikes. To scale, this kind of looks small, but this is actually about a 10 to 12 foot drop. This is holding back the entire main stem Cape Fear River. Not in the greatest of shape. They're not passable at this 3900 CFS level, but they are passable when you start moving over 9800 CFS. And we saw significant movements of striped bass that actually avoided the Nature Lake Fishway and went around the side channel and passed through this upstream opening. So that's something that we thought about. And also at Lock and M2, fish tended to be able to pass at a lower threshold than at Lock and M3, which is likely because of those added boulders that I talked about earlier. So about 9,000 to 10,000 CFS, we start to see a few fish passing Lock and M2. So maybe we don't need to always target that 17.5 threshold. And I'm about to finish up. Acoustic telemetry and eDNA were also used to evaluate fish response. I know y'all are like, okay, e-flows are great, but what's actually happened to the fish? There's like 4 different research projects going on. With my lab, we had my dissertation, Maggie Gaither's thesis. She works as a biologist on the river now. We have multiple PhD students from UNCW under the advisement of Fred Scharf. And we've also found that acoustic telemetry and eDNA have been used to evaluate these responses to e-flows. And preliminary results show that e-flows are critical at Lock and M2 and 3 during periods when the locks are inoperable. There's simply no other way for these fish to move. We've seen Atlantic sturgeon with eDNA from my work following dam submergence. And then we even saw an acoustic fish in the fall of 2024 that went all the way above Lock and M3 under really, really high flow conditions. We've seen our fish are strongly influenced by flow in general. In 2023, not 2024, 100% of American shad past Lock and M2 and 3 occurred during an e-flow, and I'll show you here in a second. There's been high passage at Lock and M2 with that a little bit less, high usage of that side channel, and then fish. This is also very interesting. Fish tend to pass upstream on the descending limb of a submergence event. And this was especially apparent at Lock and M2 in 2023. This is work from Maggie Gaither's thesis that'll be published. So, you know, we had this big flow event occurring, and then kind of on that tail end, while the submergence was still there, but these fish were able to really sense that descending limb and passed over the dam, which is pretty amazing. Okay, and then this new approach to how we're applying this work to e-flow pulses, we're working within the idea that we can go anywhere between like 9,000 to 17,000 and still have a positive impact on the river. And then applications to river herring, and I'm about to finish up. I think I'm done with time. It could be an additional tool in your toolbox, depending on the watershed conditions and depending on your upstream storage. You could have supplemental releases and time it with your herring migrations, and you might have to consider earlier submergence flows, but also consider smaller bodied herring have lower burst and sustained swimming speeds than these larger bodied fish that I'm working with. And velocity fields are likely going to be super important when you think about these small-bodied fish. But it really depends on the drop, and if the velocities exceed the volitional swimming capacity, there could be some application here, as depending on your situation and depending on the hydraulics of your system. And you think about this as complementary passage, not a standalone solution, because of climate change uncertainty. And with that, I'll finish up.
Thanks, Aaron. Yeah, really interesting system. I had a question, and then it looks like Alan had one in the chat.
Sure.
And we'll probably keep it brief, but if you can hang on, to the end of the meeting, if anybody had any follow-up questions, we can hit anything there.
Sure.
My question was, so the dam that you guys are, or the reservoir you guys are using essentially to supplement flows in the Haw River, that's not a hydropower facility, right? Is it a drinking water? Like, what's the purpose of the dam, and how's the reservoir used? Just curious, how that might have informed your flexibilities with, how you can manipulate flows.
I think I don't know the electricity part. I know it can be water supply for the area. It also is important recreationally. I'm not sure the electrical part. I know this was, that is something major that you have to consider, is how flexible it can be to allow this water to move downstream. And so that's why we have to hit all of those constraints and those enabling conditions just to get to the point of being able to do this. So
Right.
You do have to consider all of that, all of the water needs. Yeah.
The dam owner is the Army Corps, though? Is that why they were involved? Okay. All right. Interesting. And then, Alan, you're welcome to come off mute and ask your question if you want to, or I can read it either way.
Sure. Yeah. Great to see you again, Aaron.
Oh, yeah.
I was just wondering, and maybe you covered at the beginning, is there any effort to just go ahead and build new fishways or improve the existing ones so that this submergence flow is not necessary or like relied upon? And I was also just curious about what, if you're manipulating flow, what that might do to the other life in the stream.
Yeah. To your first point, I mean, there's been a legacy of fish passage issues since the inception and building of these things. So, and there's been various iterations, right? And we had really high hopes. The Cape Fear River Partnership and everybody that was involved, NOAA, everybody involved was really wanting this Nature Lake Fishway to be just a perfect model for what can happen in a main stem in a large river. And we've only seen, the success of American Shad, particularly at Lockett Dam 1. So the idea is to try to expand our knowledge, see if there are other options. The option of removal isn't really there because of the municipalities having their intake pipes directly within the pool. So there's a whole lot of other design elements that are being thought about. So we're trying hard to figure that out. What was your second? Oh, these organisms that utilize these systems, they're used to these dynamics. They're used to these big high spring flows. In fact, they're used to higher spring flows. The flows just aren't the magnitude isn't as high as what it would have been under historical and unregulated conditions. So I wouldn't really see a problem, honestly, with elevating the flow to what we do. I mean, we're kind of at a compromise with this flow. We're not going super high, but we're going just high enough to try to get these fish to pass over.
Thanks. Yeah, interesting work. Appreciate it.
Yeah, great. Thanks, Aaron. And for folks that are continuing work down on the river there, if they've got findings that are maybe of interest to the group, feel free to, encourage them to come and present at a future meeting. It'd be great to keep up with the project and progress down there. So thank you.
Yeah, no problem. Thanks for getting me up here.
All right, stay safe in the storm down there. That is, let's see. Oh no, we've got, next up we have Henry Leggett with the Smithsonian Environmental Research Center. I see you're on, Henry.
All right, so my name is Henry Leggett. I'm an ecologist at the Smithsonian Environmental Research Center in Maryland, studying river herring in the Chesapeake Bay. I want to share some preliminary results from our acoustic telemetry work, and particularly the species differences we're seeing in migration strategies between the alewife and blueback herring in the mid-Atlantic stock. This study is being done as part of a team that includes Matt Ogburn and Rob Aguilar at the Smithsonian, Assistant Chief Mark Fortune and Jack Ryan with the Rappahannock Tribe of Virginia, and Reed Nelson and his graduate students, Elizabeth and Robbie at George Mason University. All right, there we go. And I have to say, I am also about to be hit potentially by a tornado. So if I lose power, I apologize for that here in Maryland. But anyway, so for those of you not familiar with acoustic telemetry, it involves capturing a fish, surgically implanting a tag into it. The tags we use are V7s, so they're about the size of a large pill. They broadcast high frequency acoustic signal with an individual code. The way we set up these tags, they last for about 1 year. So we capture these, the fish in the creeks on their spawning grounds, tag them, release them, and then we're able to get a full year of their annual migration, as they leave the rivers, move through the bay, and then track where they go in the ocean, and then also follow them as they return to the rivers. We have gotten really good survival rates from these surgeries. So over 90% of the fish we tagged were able to track at least till they make it out of the creek and into the river, usually before something eats them. Tagged fish are then detected using these underwater receivers. So again, the tags are broadcasting acoustic signal. These are essentially very sensitive ultrasonic hydrophones. And there's a massive network of thousands of these receivers deployed throughout the bay and along the Atlantic coast. So this is a semi-recent map of that network. Every single colored dot is a receiver location. So anytime one of our tagged fish swim past one of these receivers, we know it was there. Data from these receivers then get uploaded into this collaborative data sharing network. And this is the same technology that's being used to track tons of different species of sharks and rays and sturgeons and striped bass. We have been tagging river herring in the Chesapeake Bay going on about 5 years now. We started with a pilot project of 50 fish in the Choptank River over on the eastern shore of Maryland. Results from this first project were published a couple years ago in MEPS, and this was kind of our first study of tracking the complete migration cycle of alewife. And so today I want to talk about some of our work that has since built on this initial study. Because after our pilot project, we started a collaboration with the Rappahannock Tribe and George Mason University to expand tagging to both alewife and blueback herring across 3 rivers, the Rappahannock, the Patapsco, and the Potomac, all within Chesapeake Bay. And this was all thanks to a grant from the NOAA Chesapeake Bay office. And I want to focus on this comparison of alewife and blueback herring in the Rappahannock because we now have the full annual data set for these tagged fish. And so we can start making comparisons between these species within a single river. So here is a map of the locations of where tagged fish were detected between April and December. Alewife detections are on the left. In orange, blueback herring are on the right in blue. And so each dot is an individual detection of an individual fish. So alewife leave the mouth of the Chesapeake Bay in April, and they spend April and May very quickly moving north along the coast. You know, they pass Long Island, they round Cape Cod, and then they head further offshore and spend June off Georges Bank out on the continental shelf of the Gulf of Maine. From there, they then disperse to areas along the coast of Maine and Canada for the rest of the summer and fall. In comparison, blueback herring also leave the mouth of the Chesapeake Bay in April. They also spend April and May migrating north, but they skip going offshore on the coast to Georges Bank. Instead, they round Cape Cod and stay very close to the coast, and then they spend June and the rest of the summer and fall along the coast of like Massachusetts, New Hampshire, and southern Maine. And I mean, you know the significance, or everyone here I assume knows the significance of Georges Bank, you know, extremely important ecological area for many species in this section of the Atlantic. You know, alewife are migrating to it, they're spending time there. Blueback herring from the Chesapeake Bay are not. And I would say at least that this is a pretty big difference in the migration strategies between these two species. But I do want to stress, you know, these data are preliminary. We just got them back with the most recent data push from the network. We still need to do some validation of timing of when some receiver arrays were deployed in the Gulf of Maine or not. But you know, with that validation, you know, we're still thinking about what this means for our, you know, river herring stocks in the Chesapeake Bay. And you know, I think the most obvious, biggest implication for us is this overlap of these migrations with the Atlantic herring and Atlantic mackerel fisheries in southern New England and the Gulf of Maine. So we know that Eric Palkabak's group has been looking at the genetic composition of river herring bycatch in these fisheries. This is just cut and paste of a figure from the 2016 paper. They had another paper that came out in 2023. So the left panel is, you know, bycatch from these different plots for alewife, right panel, bycatch of these different plots for blueback herring. And essentially what they found is, you know, in these fisheries in southern New England and Gulf of Maine, not much of the bycatch of alewife was coming from the mid-Atlantic stock. But for blueback herring, the majority, like 70% of blueback herring bycatch was coming from the mid-Atlantic stock. And so this is shown by these larger green slices of this pie here on this right panel. So, you know, mid-Atlantic blueback herring, this suggests they're more heavily impacted by these other commercial fisheries being caused bycatch. Mid-Atlantic alewife, maybe not as much. And I strongly suspect that, you know, the species differences in these bycatch rates are due to these differences in migration strategies and offshore habitat use that we're finding in our acoustic telemetry results. And just to show the complete cycle back to the Chesapeake Bay, so here are the detections for both alewife and blueback herring migrating back south from December to April. So they both make this southern trip very quickly along the coast, about 1.5 months. Then they re-enter through the mouth of the Chesapeake Bay, and they return to the Rappahannock River between February and March. So one last detail I want to highlight from these studies, you know, we have been tagging adult alewife for about 5 years now. We consistently get return rates every year of about 15%. Like we very much know we're going to get, if we tag 100 fish, we're going to get somewhere between like 10 to 17 fish back every single year. The blueback herring that we tagged in 2024 in the Rappahannock only had a return rate of 6%. We had 3 fish return. And in the Potomac and Patapsco, we only had 1 fish return for those rivers. So this is, at least for the 1 year now that we have tagged blueback herring, markedly lower survival rates. And so we don't know if this was just one really bad year for bluebacks. We have some older pit tag data in the Patapsco that we've started to go back through and try to do a deeper dive into some of these survival rates. But again, I don't know, maybe these differences in survival are due to those differences in bycatch between these two species. So just to re-summarize the results, we're tracking river herring using acoustic telemetry. Alewife are migrating to Georges Bank and spend June out there. Blueback are not, they're sticking close to the coast in the Gulf of Maine. I think this is causing differences in overlap with those commercial fisheries for Atlantic herring and Atlantic mackerel. This assumption is supported by these past genetic analyses of the bycatch. And then with that, we're also potentially seeing that blueback return rates are much lower than alewife. But again, it's hard to tell with just a year of data so far if this is actually a difference in survival or just an aberration that we're seeing because 2025 was kind of a bad year for river herring overall in the Chesapeake Bay. But yeah, that's what I got. Take any questions.
Thanks, Henry. It looks like we have one in the chat from Ken Sprankle. Ken, we can try and unmute you if you want to ask a question in your own voice. Let's see. James, I'll let you manage the unmuting. But
All right, 1 second, just scrolling.
sorry, I try not to also hit it because I feel like sometimes we hit it at the same time and end up re-muting people. So appreciate it.
Hi, yep. Can you hear me now?
Yep.
Hey, hi, Henry. Thanks for the presentation. A question for you. I don't know if you have the data or not, but do you know what the typical component of repeat spawners are in these areas that you're tagging?
Yeah, so thanks for the question, Ken. For alewife at least, so this is one of the problems with this is there's been for us too, there's a lot more research on alewife than the blueback herring. These return rates are kind of in line with like that 15% kind of the survivalship and what we get as these survival rates for repeat spawners is in line with our past studies and past looking at like otolith data and other genetic work that we've done in the Chesapeake Bay. So our return rates, at least for alewife, are about in line with what we expected. Again, this blueback survival rate was kind of unexpected, and that's causing me at least to go back to some of these old data, a lot of which were never published because it was just put into a state report or something, and then no one's looked at it since. So trying to go back to some of those old data and be like, did we miss something in the past with blueback? But no, at least for alewife, this is kind of what we've seen even with our untagged fat fish from studies in the past.
Okay, thanks. Yeah, it's relatively low. We know there's a gradient as you go up the coastline. You and I have talked about this because we do have a smaller group for folks that are on this call. We have a group that Henry's put together. And I'll just point out that in the Connecticut River, working with many other partners, we tagged a large number of blueback and alewife, and Henry knows this. We were just very disappointed at a very low return rate of those fish in the second year, where we do have data from scale analysis that, for example, with our bluebacks in the Connecticut River, we typically see maybe 40% repeat, and out of 100 tagged fish, we had 8 tagged fish come back as an example. And then alewife in another coastal pond, also at just a very low rate. So anyways, just some comments on that. Thanks.
Yeah.
There's 2 more chats here. There are 2 more questions in the chat. Dr. Theo Willis asked, is there anything you can say about straying rates?
Yes, so we have, so we see straying within a river system, which I think has been supported by a lot of the other literature. So within Rappahannock, we're tagging these in a single creek, in a single sub-tributary of the Rappahannock. Most fish will return to that same kind of sub-watershed tributary, but we do see some amount of straying to the other tributaries within a section of the river. And we do with some of the other partners who work with down there, like VIMS, they have picked up some of our fish, some of the very nearby, rivers. So just below the Rappahannock, for example, is a smaller river called the Piankatank. We've seen one fish stray into there. But over all these years of tagging, and then our pit tagging stays before this, we don't see that they're straying between major river systems. Yeah.
Great. There's two more questions, one from Alan and one from Maria Bate, that are both kind of asking the same thing here. So they're wondering or Alan's asking about, handling mortality and how that might affect return rates. And Maria's asking about if there's any, were you able to get a sense of any particular points in the migration period where there's, notable mortality. So I guess that they're both kind of asking, are you picking up on any, any periods in which mortality is high? Is it immediately after handling or at some point during their migration?
Yeah. So, I've got a couple points that can kind of answer both those questions. So, the mortality is kind of hard to estimate exactly what we're doing. Immediate survival rates that we've seen from tagging, so from the handling, are pretty good. They started out worse when we first started doing this project, but now that we're 5 years in, a lot of this tagging is done by, Robert Aguilar. We've gotten really good at the surgery and the suturing it takes for these fish. We can tag a fish in under 30 seconds. We get about 90% of survival of fish that we tag that we can then track out of the creek into the river. So they at least will live that long, 90% of them. But again, you observe by observing these fish, how much are you altering what would have otherwise been the natural survival rate. We do see detections that suggest times that they have been eaten by predators. So now that we've been tracking all these fish, we kind of have an idea of what we expect the migration track to be. But every now and then we'll have a tag that will leave the mouth of the Rappahannock, for example, start migrating south towards the mouth of the bay, and then suddenly shoot north. Essentially, the tag will start to behave like a striped bass. And we can then kind of assume from those results that, hey, maybe it got eaten by a striped bass. They do make what are called predation tags that will, if your fish gets eaten by a predator, there's a little film on the tag that will dissolve when it comes into contact with stomach acid, and it will start producing a dual code. So you can tell that, if I'm detecting things from that tag, it's being detected by whatever that predator is and where that's going. And before, we haven't used those tags in the past, but we have a project to start tagging alewife in the Rappahannock this year using those tags. And we're going to combine that with tags that we are also going to put into striped bass and blue cats in some of these tributaries in the Rappahannock to, try to compare these predation rates from these tags, and then also look at these movements of predators, because we see them move on and off herring spawning grounds during the season. So we are starting to do additional studies to answer that question.
Yeah, great. I know predation is a hot topic down here in the Chesapeake, so it'll be good to get a little more info on that. Matt Jargowski asked if there's any correlation between return rate and body size, or some condition factor there that you guys could use to make any kind of predictions about whether or not they'll make it back.
Yeah, so we haven't done any. So I can't tell you that I've done any. I have actual stats I can give you on that, but I can tell you anecdotally from a lot of our recent data that we've got back, both from the blue backs and the recent alewife that we tagged. the fish that usually return are the larger females. So yes, larger fish, likely older fish, are usually returned, but I don't have actual stats for that.
Okay. Yeah, no, it's great, and I feel like we'll just get a more intricate picture as you get more tags out there. I feel like that'll be your story will continue to have more, more depth to it as you get a larger sample size. So that's it's exciting work, and I think folks here are excited about it. Last question for you, and then we'll switch over to our updates. But Maria asked if there was a different receiver required for the predation detection tags. My sense is probably not, but I've not dealt with them. So you want to speak to that?
No. So yeah, this is all the current receiver networks can pick up the same codes from the tags.
Gotcha. Okay. Great. Well, we will skip over to the updates. If folks have lingering questions for Henry, and Henry, if you're able to stay on for the open discussion, we can certainly keep chatting about your tagging study then. But we'll do 30 minutes updates here, and then our last hour, or maybe a little bit less at this point, is reserved for open discussion and member updates. So we can get to any outstanding questions then. Thanks so much, Henry, for giving us an update on your work. Our next presentation is from Becca Cusick at UMass.
Well, thank you all for hanging with me there. My name is Becca Cusick. I'm a graduate first-year master's student at the University of Massachusetts at Amherst. I'm co-advised by Dr. Allison Roy and Dr. Adrian Jordan. And today I'm presenting on not just for the birds, impacts of water level management on river herring within a managed tributary of the Schoodic or St. Croix River in Maine. So you're probably wondering, oh, this is a presentation about river herring. What do birds have to do with that? So if you'll come along and swim with my school, I'll take you on a little journey of how those two connect to each other. So as I'm going to be building on some of the previous themes of some of the earlier presentations, but as all of you know, I'll probably skip through this pretty quick. Dams and diadromous fishes. So dams impact on diadromous fishes. So there are various types of dams all throughout New England. Almost all streams in New England have some sort of dam on them of various style, sizes, and uses, such as for flood control, for hydroelectric power generation, and for water supply for folks. And these can lead to these dams create impoundments for those water body purposes, and those can lead to barriers for passage for various diadromous species. Fishways, we use those to get around some of those barriers and can allow for fishes to move through and around those barriers, upstream and downstream passage, and sometimes multiple times a year and various times in a fish's lifetime. So sometimes when those barriers are mismanaged, this can lead to crashes in populations, such as on the St. Croix River in 2002. And these barriers have been, this river has been on a resurgence since this population crash. So what's less talked about sometimes are dams in smaller tributaries. So hopefully folks aren't too motion sick like I am, but I can play this video for y'all. This is a video of a drone footage over my study site, so Upper Magarowak Marsh, which is a tributary of the St. Croix or Schoodic River and part of my project site. So this shows just a rocky cross dike that breaks up this tributary into various impoundments, and you can kind of see where that car is in the middle. That's just past that is actually a fishway structure with some water control structures attached to that. And that water control structure, the refuge had used to keep water levels at a certain height throughout the year at various flow rates. So throughout the spring, these water levels need to be kept at certain heights for management targets. So spring freshets and backflow from the Schoodic main stem contribute to high spring water levels and allow for early migrants in the system, river herring migrants, to easily access the rest of the system. But as the season progresses, the water level drops slowly, and these water levels actually need to be kept consistent throughout the year so that they don't negatively influence nesting and breeding migratory birds that are also using this system, which that can actually lead to some management complications when it comes to river herring, as the CFS flowing out of, for this example, this fishway, which is the downstream-most fishway in the system, can lead to some challenges with high flow rates early in the system when trying to keep those water levels consistent in the tributaries upstream of these fishways. So, and like I said, mostly these have historically been managed for migratory birds and waterfowl production, so waterfowl and secretive marsh birds such as Sora, American bittern, Virginia rail, and American black ducks. So some of the problems that my project is going to try to address are impacts to river herring passage. So river herring are relatively newly populating this system, so there's not much known about where, how they're using these fishways, where they're moving to within the system. And if the current management plan targeted towards waterfowl may be impacting upstream and downstream passage of adult river herring and juvenile river herring as well. The use of available habitat, so how river herring are using the available habitat throughout their ontogeny, throughout the tributary. Where are they going? Where are adults spawning? Where are juveniles being reared? And looking at multifaceted water level management. So each of these pinch points and the outflow to each of them, they kind of have their own quirks, and they flow into each other. So management at one upstream fishway will directly impact the downstream fishway and the management of that fishway. So looking at what changes may affect the next fishway downstream or the next impoundment downstream, and how that the accurate and precise management of those may impact movements of river herring in the system. So my objectives for the study are to investigate spatial patterns in adult river herring movements, quantify juvenile river herring densities within each of these 4 connected impoundments, and to investigate how river herring may be impacted by water level manipulation. And I just want to preface that since I am a first-year master's student, everything moving forward is preliminary pilot data, and I will be continuing this data collection throughout this upcoming field season. So for my study site, this is a map of the Schoodic or St. Croix River watershed. This river makes up the international boundary between the United States and Canada, and it is located entirely with the Passamaquoddy tribal homeland. So in the green, you can see Moose River National Wildlife Refuge. That's the Bering Division. This is part of the Northern Maine National Wildlife Refuge Complex. And where the gold star is actually where Megarawak Stream and my study site lie. And as you can see, additionally on the map is in black the Milltown Dam, and just southwest of that is the Woodland Dam. So river herring will actually migrate in past the Bay of Fundy, through Passamaquoddy Bay, up into the St. Croix River, past the recently decommissioned Milltown Dam, and into the refuge. So like I had said, the Milltown Dam was recently decommissioned in 2023. That's what it looked like before, and that is what it looks like now. So again, they'll swim in through the St. Croix River and past the Milltown Dam and into Megarawak Stream. Once they reach into Megarawak Stream, they can move down the east branch all the way to Vose Pond, or to the west branch down to Howard Lake. This study site is really important because Moose River National Wildlife Refuge was actually established in 1937 for waterfowl production and migratory bird habitat. And this is a really primary site of conservation concern and need for tribal, federal, state, and international partners. Because while this site only makes up about 2% of the available spawning habitat for river herring in the greater Schoodic River system. It is the first accessible tributary on the United States side of the St. Croix River for river herring to make it to. And in 2024, refuge staff observed about a 300% increase in river herring returning after the Milltown Dam was decommissioned. So for my first objective for this research, I will be looking at adult river herring relative abundances in the system. So river herring have never been counted in the system before, so we're looking at video data in this system and looking at river herring moving upstream for the upstream spawning run. And this past year was the first 2025 was the first, I guess, official count in the system, and there were about 42,000 upstream running river herring, which I think made up about 10% of the total count in the system comparatively. And using video assessment, like I had mentioned before, we're also looking at upstream and downstream movements and timing of those movements, as well as bycatch. So we're collecting a record of bycatch. This Daniil system was implemented in about, I think, the 1950s. So there's a lot of other species that use this system. We've seen chain pickerel, otter, largemouth bass, snapping turtles. We've had some sea run brook trout as well. So just looking at who else is using the system, predator abundance and absence, and various instances of other species in the Garewalk. So additionally, for my first objective, we're looking at adult river herring movements. So the run in this part of the Atlantic coast happens from late April, early May, all the way through June. We'll be capturing adult river herring proportional to the run density to keep with methods from other local partners that have been monitoring river herring in the system for a number of years now. And we're going to be using 23mm HDX passive integrated transponder tags. And we will be implementing 4 antenna arrays at the 4 pinch points of fishways at each of the red markers on the map to the left. And we'll be looking at upstream movements, downstream movements, and returns, as there were previous studies of pit-tagged fish. So we want to see how many are returning, if there are any returning, and when they return. For my second objective, we're going to be looking at juvenile use and densities of each of these water bodies. So looking at 5 target lakes and impoundments. So for the lakes that are deeper than 2 meters in depth, we'll be using the pelagic purse seine method at night, such as similar to this picture on the left. And for the impoundments that are more shallow than 2 meters in depth that we are not able to use the purse seine in, we'll be using various methods such as beach seining, cast nets, and minnow traps to catch juvenile river herring. We'll also be collecting water quality data, so looking at dissolved organic carbon, dissolved oxygen, total nitrogen, total phosphorus, as well as chlorophyll A, and conducting zooplankton tows, so vertical for the deeper impoundments and horizontal for the more shallow impoundments, and looking at species composition and density of those species. And additionally, for objective 2, we're going to take up a subsample of 50 collected juvenile river herring, and we extract their sagittal otoliths. We mount them on slides, and we image them using an Image Pro software, and we actually age them to the day. And we're also collecting data on water level manipulation. So looking at these 4 fishways and pinch points that are the outflows of various impoundments, we'll be implementing non-vented pressure transducers and collecting manual records of water level heights, and recording management actions such as metal or wooden stop logs added, how that may affect the water level in each of the impoundments, and potentially like pitch of each fishway that can be manipulated, and other such data. And that will be at the same 4 locations as the pit antennas that we're deploying. We will also be deploying temperature loggers at these 13 sites. So implications of this research are very multifaceted. The first of which are going to be directly informing refuge management actions. So based on river herring use and structure-specific actions, the refuge wants to create a plan of how to best manage each of these sites individually and in unison, temporally throughout a certain year. And just improving system connectivity. A lot of these fishways have been more in relative history have been more recently implemented, and that has just greatly improved aquatic connectivity, not only in Magarawa Stream, but in the greater Schoodic River system. Touching on some of the previous presentations, just restoring some ecosystem services. So looking at system level connectivity, as I had mentioned before, improving the marine-derived nutrient exchange within the tributary and the greater system, and improving forage. So for obviously humans, birds, fish, reptiles, and mammals in the system that depend on these fishes. And the management of critical habitat. So for Magarawa Stream, again, just to drive that point home, improving aquatic connectivity for river herring use and for all the other species such as birds that also use this system. And more importantly, I guess, looking at the Woodland Dam. So the Woodland Dam Fishway is actually going to be, which is the upstream dam just upstream of Magarawa Stream on the Schoodic River. Their fishway is going to be closed to passage in 2026 and potentially 2027 for passage improvements. And therefore, Magarawa Stream is going to be one of the only tributaries that river herring are able to spawn in this upcoming year. So accurate management is absolutely imperative and critical for the continuation of the river herring population in the Schoodic system. So with that, I wanted to take a moment to thank all of the folks involved. There's quite a few. So my advisors, refuge staff at Moosorin, Project Share staff, my lab mates who have helped with data collection, the 2025 field crew, my various local partners, some of which are on this call today, and our small army of undergraduate practicum students who have helped us with everything from otolith extraction to aging those otoliths as well. So thank you all, and happy to answer any questions you might have.
Thanks, Becca. Seems like quite an effort. You're collecting a lot of different types of data, and while I'm waiting for folks to see if they've got anything to answer to the questions box, certainly, once you're wrapping up there, would welcome you to come back and share some of your findings with everybody here. It seems like you'll have a pretty full picture of the dynamics in that system based on all the different data sources you're collecting. So yeah, just impressive effort there, and best of luck as you, I'm sure are starting to think about ramping up for the spring season.
Thank you so much. I appreciate it.
I'm not seeing anything in the questions here. Oh, Alan had one. Alan, you want to ask? You can unmute.
Yeah, sure. So you mentioned that some of those fishways that they can actually change the pitch. Is that just by some kind of crank, or I mean, how's that work?
Yeah, so two of the fishways are Alaska Steep Pass style fishways. So they're like the metal, I guess, rectangular prism type. And they were implemented because the water control structures, they're kind of in a weird spot. So they were implemented actually after those water control structures were implemented to allow for fish passage. And there's a crank on the upstream side and the downstream side, so you can change the pitch of the fishway based on the water level of each side of the impoundment.
Okay, cool. Thank you.
Of course.
Great, thanks again, Becca. Best of luck. For the second time, we'll go ahead and over to Brian Dieterman at University of Southern Maine to talk about his work on the Kennebec.
All right, so yeah, we're looking at the Kennebec River here in Maine, and we're studying specifically juveniles of American shad, blueback herring, and alewife. And we also have just an incredible amount of collaborators and supporters, so I just want to shout them all out to start. I don't really have time to do individual thank yous, but they're all absolutely crucial. And this is a pretty there's a lot going on in this project. So I'm going to kind of really hit on kind of the high notes and not really get too in depth into anything. But essentially, there are two main research questions that we're looking at here. The first one is when we look at these three very similar morphological fish, do they have differences in the way that they use the river in terms of diet and habitat? So basically, are they partitioning resources and how are they using the river? And we're looking at that in two different ways. The first is using their stomach contents to kind of characterize what their diets are. And then we're also using carbon-13 and nitrogen-15 stable isotopes, which thankfully have been introduced very thoroughly previously here. And then the other question is the Maine Department of Marine Resources does a beach seine survey that is for these juvenile allicines. And since that beach seine is only really looking at the margins of this river that's incredibly deep in some places, is that survey missing parts of the populations of these fishes that might be using those deeper sections of the river? And so we also had two ways of looking at that. The first one is going to be some hydroacoustic surveys, and the second was eDNA. And with the eDNA, we use both the qPCR with some species-specific probes and primers, and then we also did metabarcoding at a limited number of sites. And so for that question one, and to collect the samples, we use that aforementioned beach seine survey with a Maine DMR. You can see a picture there on the left of the survey in action. And on the right is a map of the samples. So the survey goes from Waterville down through Phippsburg, which is the undammed section of the main stem Kennebec River. And we also separated these sites into 4 distinct river reaches that we looked into. From Waterville to Augusta, that's going to be what we call the upper river, and that is going to be non-tidal freshwater river. Then once we get past Augusta, where the head of tide is, from Augusta down to Richmond, that's going to be freshwater tidal river, and we call that section above Mary Meeting Bay, because the next section is Mary Meeting Bay, which is a tidal freshwater bay, which is a really cool feature of the Kennebec. This is a very rare thing, but 6 rivers worth of water flow into there and kind of hold the salt water at bay and keep it fresh water. And then once you go below that, we have finally our estuary, which is going to be brackish tidal river. And so then moving into our diets. So that survey goes July through September each year, but for the diets, we focused simply on July because that's when the most fish were caught and so we had the best sample sizes without having the confounding factor of possible seasonal shifts in the prey availability. And even with this, you'll see that bluebacks have a few holes in the data simply because in above Mary Meeting Bay in the estuary, we never really caught a significant number of the bluebacks. So when we're looking at this figure here, it's paneled by the 3 different species. On the y-axis, we've got all of our different species for prey, and then the x-axis in each panel, we're moving from left to right through the reaches, from the north through the south, upper river through the estuary. And then the heat map is going to be the frequency of occurrence for these diet items. So that's just going to be a measure of what % of diets was each item found in. And a couple of things right off the bat, we did over 300 diets, and throughout the course of the study, only 3 of them were empty stomachs. So we're seeing that these fish are actively feeding pretty much throughout the river. And you can also see by the way this heat map is set up, that as we move across the river reaches, the diet items that they're eating do change to kind of reflect that reach. And I'll also highlight a few things. One similarity we have throughout the course of the river system for the species is that they're all eating larval dipterans, which are primarily chironomids, non-biting midges. You can see a picture of one that is actually in pretty good condition there on the left. And so all 3 species, we're seeing pretty high frequencies of these outside of maybe the estuary. However, when we focus in on some differences, when we move into the pupal stage of these dipteras, while they're appearing in all of the species diets, they're significantly higher in the shad. On the other hand, for both river herring, we're seeing cladocerans and copepods being much higher frequency in those river herring diets. We see a picture of some bosmina, which are most frequent cladocerans that we're finding. So we are seeing in these diet contents some differences, but especially between the river herring and the shad. we move on to look at our isotopes. Here, once again, we have the 3 species separated into panels, and the points are going to be the mean values for those species in each reach, with the error bars being standard deviation. On our y-axis, we've got the nitrogen 15. The x-axis has our carbon 13. And there's also on the x-axis our carbon pathways for benthic and pelagic signature. So our pelagic signature is going to come from mussels and benthic from snails. And you can kind of track the carbon pathway because carbon doesn't really undergo much trophic fractionation. So as you move up trophic levels, it remains relatively the same. And we can see if we look at our red circles for the upper river, that we're once again seeing that difference between the river herring and the shad, where the river herring are really falling closer to that pelagic pathway, where the shad are much closer to the benthic pathway. And then we're also seeing that as they're moving through the system, their tissues are adjusting based on the reach they're in. So if we look at the difference between where they are in that upper river by the time they get to the squares in Merrymeeting Bay, we're seeing a pretty big shift in the nitrogen, which a lot of times a shift in nitrogen can be indicative of a trophic shift, but we're not seeing a trophic shift in the diets. And we're also seeing, when we look at the mussels, especially in Merrymeeting Bay, they are enriched compared to the upper river. So this is a good indication that they're spending a decent amount of time feeding and growing here in these different reaches. And we can also see this further as they move from Merrymeeting Bay into the estuary. We're seeing an enrichment in the carbon, and that is pretty indicative of a more marine signature. So as they're moving into this brackish water that's seeing that good influence from that ocean water, we're seeing that enriched shift in the carbon. And that kind of backs up the same things that we're seeing in the diets. Moving on to our hydroacoustic and eDNA surveys for question 2. So this, we kind of zoomed in a little bit on the river. We only did it from about the last side of Merrymeeting, above Merrymeeting Bay section, down through the estuary, because this is more of a pilot program to kind of test the concept, proof of concept here. So we have 6 sites where we took eDNA. You can see those are the dots on that map, and they were chosen to be as close as possible to the Seine sites. And at each site, once a month, within a couple of days of both the Seine going and the hydroacoustics going, we took eDNA. So within the same 3 to 4 day period, all these surveys went on. eDNA, we took a surface grab as well as a sample from about 1 meter or 2 off the bottom. And then we kind of combined those to integrate the whole water column as best we could. And that track for the hydroacoustic survey, that's specifically the transect. It went in June, or in July, I mean. The August and September surveys are pretty similar to that. And on the left, you can see a picture of us taking our eDNA samples and running the hydroacoustics. So moving into the comparison of, this is going to be our species-specific qPCR, so our quantitative eDNA, our beach seine catch of allocenes, and hydroacoustic detections that we filtered it for fish that are in the 3 to 9 centimeter total length range, because that is the length range of the allocenes that we caught in the Seine. And so on our y-axis is going to be our catch, our hydroacoustic detection, and our PCR eDNA concentrations. And I think it's important to note that there is not like a translation from an amount of eDNA to a biomass or amount of fish. What we're really looking in this figure here is just that kind of patterns of detection more so than absolute numbers. And on our x-axis, it's once again the latitude. We're moving from our northernmost sites on the left right to the southernmost sites. And kind of one of the things we can look at right away, especially in July at this northernmost site, that's our highest eDNA detection of the whole survey. We had still in August pretty high eDNA detection. Hydroacoustics, we're detecting quite a few fish in that 3 to 9 centimeter range. But in July, for the beach seine, had 0. There's no dot on there, but there was 0 allocenes then. And in August, very few. So we're seeing the beach seine possibly missing at the top of this survey here, quite a few allocenes. And then we once again can see that if we look towards the right side, now we're down in the estuary. And this is where the river is the deepest. Some parts here are up to 30 meters deep. And so the beach seine survey is detecting allicines, but not nearly as much as what we're seeing in the eDNA and kind of the corresponding detections in the hydroacoustics. Although there is the one site in July, the last site in the survey, where there was no eDNA detection, but there were some detections for the beach seine. So it does kind of have a back and forth. Sometimes one survey is better than the other. So then we also did, like I said, some metabarcoding. So there's kind of a lot going on in this figure here, but essentially what you're seeing is the species composition. So this is like what percent of the catch is what species. And we took from the metabarcoding, we eliminated species that are not pretty much ever caught in the Seine. So there's a lot of Atlantic menhaden DNA, which we assume is pretty much from adults that are in the system, because we're not catching menhaden really in the beach seine survey. So this is 4 sites. We've got July on top, August on the bottom. Beach seine and metabarcoding are side by side for each site. And the biggest takeaway for this one is that we're getting more species detected in the metabarcoding. We're getting a lot more species richness. And you can especially see in most of those estuary samples, the mummy chug section is totally overwhelming the beach seine survey. So it's really overemphasizing, according to what we're seeing in the metabarcoding, how much the mummy chugs are dominating the community there. And then we can also just kind of zoom in this metabarcoding and beach seine on just our Alicine. So this has just the river herring and the American shad highlighted. Once again, moving left to right, we're looking north to south. And this kind of reinforces that northernmost site where the beach seine is not finding river herring, that the river herring are actually pretty abundant in that area, according to the eDNA. In the middle, we do see a good amount of, both surveys are finding the same thing. And we're even seeing a couple times here in the estuary where the beach seine survey is once again detecting some of these allicines that are being missed by the eDNA. So I think that the really big takeaway here is that no one survey is foolproof for consistently detecting these fish when they're present. So kind of the conclusions from everything here, big picture. We do have some pretty good evidence that there's resource partitioning going on in the diets and stable isotopes, and that's particularly evident between the river herring and American shad. Though when you get into the nitty-gritty, there is differences between the bluebacks and the alewife. We're seeing that these juveniles are spending enough time feeding and growing in the river that we're seeing changes in both their diets and their stable isotope contents. When we do the metabarcoding, it's finding a higher richness of species than the beach seine alone is. And really what it comes down to is that multiple survey types combined are going to give you the best coverage. Essentially, if you just do the beach seine, you're going to be missing fish. And if you add on other surveys like hydroacoustics and eDNA, you can increase that coverage and be more confident in the community determinations that you're making. And thank you, and I'll take any questions.
Thanks, Brian. So you are in the process of wrapping up, is that right? And I guess what's your timeline there and publication? What are you thinking?
So yeah, we're wrapping up that metabarcoding data. I actually just got, it's been about 2 weeks now. So we're trying to really get through kind of processing that, finishing up writing my thesis and defending that in May, and hopefully publishing quite soon after that.
Great. Yeah. It seems like you've got pretty much all the pieces are there. Just continue to put the story together. It's a very rich data set. So
yeah, exactly. There's a lot of data. Finding what it really tells the story is the only difficult part left, I guess.
We had a couple of questions in the chat here. Alan, as always, I'll let you unmute and then and ask your question.
I'm just full of questions today. That's really interesting about the eDNA and the hydroacoustic detection. So I was just wondering, since the eDNA could be mixing throughout the water column, in other words, if you get eDNA out there in the deeper water, it may have come from somewhere else where the fish was hanging out. So it seems like the hydroacoustic detections, you're getting, something right then and there. So is the eDNA just a way to confirm those hydroacoustic detections? So you'd still need the hydroacoustic detections. You couldn't rely just on eDNA, I guess is the question.
Yeah, that's definitely kind of our thinking. When we initially planned the project, we didn't even have the eDNA wasn't part of it. That's kind of, we added it on based on that thought, that when we have the hydroacoustic detections, we have the SANE that's not right there. So another piece of the puzzle to kind of try and figure out what might be in those detections would be the eDNA. So I do think that there is a lot of benefit from having both of those, because absolutely the eDNA is not guaranteed to be from nearby. And I think, that's kind of exemplified by the fact that our northernmost site was the one where we're seeing a pretty significant amount of river herring DNA, but we're not catching any in the beach seine. And that could very well be because there's a lot of river herring just above there in the river, which is unfortunately a section of river that's like very rocky ledge. And so it doesn't lend itself to the beach seine at all. So it could be that the beach seine isn't missing fish that are right there, but it's just missing fish in the nearby area.
Yeah, one of the things we use for juveniles is we use a push net, which you do at nighttime when the fish are near the surface, since they're negatively phototropic. I don't know if that's an option for you up there, to use something like a push net out in the middle of the river.
Yeah, I don't know. I don't have experience with push nets. I know that navigating the Kennebec at night would be dicey.
Okay.
And the flows can get pretty wicked in the estuary too, but it'd certainly be something to look into.
Yeah. Thanks. Very interesting work.
Mm-hmm.
Yeah, thanks. And Gareth had a question about did you use a commercial lab for your metabar coding, and if so, which lab did you use?
Yeah, we used the Hubbard Genomics Center at UNH. And we had them do the bioinformatics too, which was a huge help, because I don't think I would have had time to do that myself. So that would have been a huge lift.
Well, Brian, thanks for coming again to give another update to the forum. And yeah, certainly as you wrap up, if you want to come back in and cap everything off with, if there's anything drastically different from what you've already presented, or, or any specific things you want to kind of focus on in future River Herring Forum meetings, certainly welcome to come back and share your wrap up with us there. But appreciate you coming today.
Absolutely. Thank you.
And that is our last presentation. We have now about 43 minutes for open updates. So folks want to raise their hands if they've got anything to share for the good of the group. Recent passage improvements, observations. Brian, we still got your screen, by the way. But folks, this is supposed to be an open forum for information exchange up and down the coast. So certainly welcome folks to chime in. If you want to raise your hand, we can unmute you. Otherwise, let's see, I'll just reiterate what we said earlier about the fall River Herring Forum meeting. It looks like we're going to move that date, and we will send that out in the email, but I had it up in my calendar. I think it was October 26th we're looking at. James, you can confirm. Yeah, the 26th.
Yeah, that's right.
So we'll do that. Hopefully, that'll work for folks' schedules. I know this time of year is tough for some, as the run's already ramping up in some of our southern areas. So appreciate it. The folks that showed up today, who are already out there, working on the water, trying to catch the beginning of the runs. What else do we want to add for the good of the forum, James? Anything in particular?
I think that's it. We can also shout out if anybody hasn't already signed up for our weekly report, we can also send out the link to that form as well.
Yeah, Right. So we kind of carried on some work that Ben Gehagen had been running this weekly report, trying to run numbers up and down the coast, kind of, on a weekly basis. So we do pull together information from, folks monitoring up and down the coast to get a sense of, the status of their runs. I think my sense is the folks in the northerly climes appreciate it because it gives them a heads up that, the run has started to the south of them, and they can kind of be ready to catch the beginning of the run when it gets to them. So yeah, feel free to, let's see, maybe we can put the link to the form to sign up for that distribution in the chat here, and then I can also send it out to the forum. I'll make a note to do that. And then while I've got the floor, I see Kevin's got his hand up. We'll pass it over to you in a sec. But yeah, just wanted to put in a plug for some of the river herring related festivals that are out there up and down the coast. As many of you know, it's a great way to keep some of these species in the public eye that maybe don't get as much publicity as other charismatic fauna. So I've been trying to keep an eye out for river herring related events in the spring, and send it out to the forum. If folks have anything that they'd like to share with the rest of the forum, please share it with James and myself. We can get those events out as like a little addendum that we include in our emails. We can include that in the wrap up for this meeting. But yeah, just really glad to see some of these festivals are still pushing forward. I think like the Mystic River, it's their 30th annual festival, so that's great. And then globally, there's World Fish Migration Day, which is May 23rd. So again, just trying to make folks aware of some of the the public engagement pieces that are still ongoing on the coast, and encourage folks to get involved or just attend those events. Kevin, you got some updates to share with the group?
Yeah, am I coming through okay?
I gotcha.
Awesome. Yeah, I just figured I'd give everybody a heads up. We've got alewives running in Connecticut. I started on the 6th, I want to say. Still small numbers, but our best night's maybe 50 fish right now, so really nothing, but it's just nice to see, nice fish coming in. A lot of big females, it looks like, is basically what's coming in right now. And I did want to follow up. I know last fall I'd given everybody an update that we'd had a better year, but we finally were able to run the numbers over the course of the winter here. And so this year we were up 39% over last year, total combined species across the state. And then that was up, we were up 36% the year before. So we're hopeful that that'll continue going into the season here. We'll see. We think we've got a, pretty good shot coming in with, a lot less effort going on at sea, and we've added more fishway projects going on. So with the hope that there's less bycatch going on with reduced effort out there, and then more stocking and projects going on, we're hoping to see continuation of what we've seen the last 2 years here. So that's about it. Thanks.
Yeah, thanks, Kevin, for that Connecticut update. I guess I didn't realize the heat wave had triggered things all the way up in Connecticut. So that's interesting. We'll include that little blurb in our weekly report. Anyone else raise a hand, share what you're working on with the group, what you're seeing in the field, requests for future meetings, topics you want to see us explore in more detail, or presentations you've seen that would be of interest. Certainly open to those suggestions. Alan, go ahead.
Yeah, just an update for Virginia. I can report that VIMS started seeing some alewife in the lower Chickahominy River probably a month ago. And then several weeks later, we finally started seeing them about 24 miles upstream. Just all of a sudden, they're hitting the fishway, a whole bunch of alewife going through. And we're starting to see them boat electrofishing on the James and the Rappahannock. I think pretty good numbers of hickory shad also on the Rappahannock. And Shad Cam went live this morning at the fishway at Bossier's Dam. And I could drop the link. If I'm not exactly sure how you how I can put something in the chat. You just Google ShadCam, you'll get it. But I see the chat, but I'm not sure how to drop a link in there.
I can, I'll send the ShadCam link out to the forum in the meeting recap. I watched it for a little bit this morning, didn't see anything going through, so.
Yeah, over the last couple of days, I saw some sea lamprey were moving through and some smallmouth, and it was just the direct link, but now there you go, and now it's live. Thanks. So yeah, kind of a slow start, but now all of a sudden things are happening, and of course this weather front might affect things for a few days. The South Anna River has been too low, but to sample except once. I don't know how much I reported in the fall, but we did see both alewife and blueback herring upstream of the dam in 2025, along with American shad and hickory shad. So we're into year 2 of monitoring post removal of that Ashland Mill Dam. That's all I have for Virginia.
Thanks, Alan. Yeah, appreciate you sharing that. And yeah, I'll be interested to see how things continue to go there at Ashland Mill. I guess I can, for Maryland and just the piece that I'm involved with, we, through the Susquehanna River Anadromous Fish Restoration Cooperative, we're in the process of updating the migratory fish restoration plan for the Susquehanna River Basin. It was the current version is from 2010. We're going to try to update the plan with including some modeling using the Anadra fish program that Dan Stitch has developed and has presented previously at the forum about that modeling framework. So anyway, hopefully we can get through that this year, and once we're done, I figure it could be of interest to folks at the forum at the very least if we presented a little bit on how we updated the plan and how we structured the Anadra fish model to answer some of the management questions that we have for the basin. So that'll be something I'll aspire to bring to the group in the future here. And yeah, that's what I've been working on, at least partially through my normal duties here with NOAA. Trying to think what else. I think that's about the only management update that I have for this group from my office. At least from the work that I directly do. Obviously, NOAA touches on a lot of different pieces relative to river herring, but I can't speak on behalf of all of those activities. So, any other comments, questions, requests for the group? I think I'm not seeing any more hands, so we'll say it's our last call, and we can, just try and hear from everybody here.
Hey, can you hear me? This is Aaron. I didn't see where I could raise my hand, but I am a panelist, so I don't know if that matters. Anyway.
Yeah, go ahead, Aaron.
Sure, yeah. So I'm working on some pretty intense climate models, looking at river warming and flows and how that relates to fish migrations and timing. And there's probably some folks on this call that have done similar things because I've seen some of your literature. But I'm doing this across a full swath of anadromous fish on the Roanoke River in North Carolina, including river herring and blueback herring. And so I'd be happy once I get that kind of in a better place, I'd love to be able to discuss that with this group as well. So that's
that would be great. I think that's super relevant to management, just given the shrinking temperature windows that we're seeing, and trying to add more context to that conversation would be great. So we'd love to have you back.
No problem. I'd love to do it. Thank you. Thanks for having me today, by the way.
Yeah, thanks for coming. Yeah, for our panelists, because you're a panelist, you can't raise your hand, but you're certainly welcome to chime in. I know, James, you got anything else you wanted to share with the forum today?
I don't think so, except to say we are wrapping up then, to thank all of our presenters again. And that we'll be reaching out for presenters for the next meeting. Oh, I see a question in the question tab. But we'll be reaching out to our presenters for the next meeting about a month or so, I think, in advance, if you hadn't mentioned. I'm not sure if you mentioned that already, of the new date, October 26th.
Yeah, right. Well, James will clean up the recording and then post to the web, and that's usually when I send out the meeting recap. So we'll include, the relevant links that were shared today, so folks can easily access those resources. Maria, you asked about the Anadromous fish model. I can send that to you, no problem. Well, great. Yeah, with that, we can wrap a little early. So want to thank everybody, especially our presenters, for participating today, and we look forward to reconvening in the fall. Like I said, in the meantime, if you've got interesting papers or news articles or presentations you've seen, please continue to share that information with James and myself. James and I are both in the Mid-Atlantic, so certainly don't have our ear to the ground on every river herring issue up and down the coast. So you guys are our eyes and ears in different parts of the range, and appreciate you keeping us abreast of what's going on with management, conservation, and restoration in your respective watersheds. So thank you. And we will see you all in October.